This is a tough Olympiad question and we want to simplify it in this video. So you want to watch this video to the end. The question appears simple, but it is not actually simple. We are to find the value of x in this exponential equation. How do we solve this? The first thing we want to do is to take away the square root from the right hand side. And to do that, we need to square both sides of the equation. So we are going to have 2 raised to power x minus 3 raised to power x all squared equals 6 raised to power x minus 9 to the power of x. The square root is gone and the equation is getting simpler. At this point, we want to make sure that all the bases are in the base of 2 or 3. This is in base 6 and this is in base 9. So let's work on the right hand side to keep them in bases of 2 or 3. So we are going to have 2 to the power of x minus 3 raised to power x all squared equals 2 times 3 to represent 6, and that is raised to the power of x, minus 3 times 3 to represent 9, and that is raised to the power of x. So we have everything in base 2 or base 3, which will help us simplify the work. You agree with me that the power of x distributes over 2 and 3. Similarly, the power of x here distributes over these 2, this 3, and this 3, which means we can rewrite the right hand side as 2 raised to the power x times 3 raised to the power x. The x distributes over 2 and 3, minus 3 raised to the power x times 3 raised to the power x. The same reason. Everything is equal to 2 raised to the power x minus 3 raised to the power x all squared on the left hand side. Now we have this equation, we can factorize the right hand side because you would have observed that 3 raised to the power x is common to both sides of the expression on the right hand side. So by factorizing the right hand side, we are bringing out 3 raised to the power x, and what will be left with here will be 2 raised to the power x minus, if this goes into this, we'll be left with 3 raised to the power x. So this is the equation, and from here what we need to do is to take the right hand side into the left hand side. Why are we doing that? Do not make the mistake of dividing both sides by 2 raised to the power x minus 3 raised to the power x, because you can see it is common to both sides. That it is common to both sides doesn't mean you should divide both sides by 2 to the power of x minus 3 to the power of x. If you do that, you'll be solving it incorrectly. Reason being that the unknown is contained here, so you don't want to be dividing both sides with the unknown when you don't even know what it is. So the best way to do it is to move everything to the left hand side and equate to 0. So if this crosses over to the left hand side, we have the entire equation equal to 0. That way you can factorize out the common thing between both sides. By factorizing out is different from dividing because you still have the whole expression retained. So 2 raised to the power x minus 3 raised to the power x is common to both sides. So if we factorize it out, 2 raised to the power x minus 3 raised to the power x, we factored it out. It goes into this squared. You'll be left with 2 raised to the power x minus 3 raised to the power x, because this and this will form this squared. This negative is this negative. This goes into this and we will be left with 3 raised to the power x. So this is the factorization of the left hand side, and everything equal to 0. At this point, you can now tell that either this is equal to 0 or this is equal to 0 for this equation to be 0. This is what we mean. Either 2 to the power of x minus 3 raised to the power x is equal to 0, or this expression here is equal to 0. It is when one of them is equal to 0 that their product can give you 0. Now we have two equations that we can now solve independently. Let's start with this one. So I'm just going to create a division here so that we solve this on the left and we solve this on the right. So from this, you can move this to the right hand side so that you have 2 raised to the power x equals 3 raised to the power x. Here, you divide both sides by 3 raised to the power x. And if you do that, you're going to have 2 raised to the power x divided by 3 raised to the power x equals 1. This power of x is common to both sides, so you can bring them together to a common power of x. So we have 2 over 3 to the power of x equals 2 over 3 to the power of 0, because anything to the power of 0, so long that thing is not 0, we give you 1. So we are just taking them to the same base. And you agree with me that now that the bases are the same, it means the power is the same. So we have x equal to 0. So this is one of the solution to this question, but it is not the only solution. So we need to find the value of x from the other part. So on this side, we have minus 3 to the power of x minus 3 to the power of x. That should give us minus 2 times 3 to the power of x. We have 2 of it. So we have 2 of 3 to the power of x. Remember, negative, negative, it retains negative. 2 to the power of x minus 2 times 3 raised to the power of x equals 0. Again, we move this to the right-hand side so that we have 2 raised to the power of x equals 2 times 3 raised to the power of x when this crosses over to the right-hand side. From here, it is getting simpler. Let's take all the x's to one side. So we need to divide both sides of the equation by 3 to the power of x, just the way we did here. So here we're going to have 2 to the power of x divided by 3 to the power of x equals 2. By the time you divide both sides by 3 raised to the power of x, you have 2 on the right-hand side. Again, the x is common to the numerator and denominator, so we can raise numerator and denominator to a common power of x, and that's equal to 0. Let's move to the next page to complete the solution. So this is what we've got. This is x equal to 0 from the previous solution, and this equal to 2. To solve from here, we need to take the logarithm of both sides of the equation because nothing is common. No common base, no common power. So let's take the logarithm of both sides of the equation. If we take the logarithm, we are going to have log 2 over 3 to the power of x equals log 2. This implies that this x can multiply the logarithm on the left-hand side. So we have x multiply log 2 over 3 equals log 2. We are looking for x, so it makes sense to divide both sides of the equation by log 2 over 3. If we do that, we are going to have x equal to log 2 divided by log 2 over 3. If you like, you can leave this as your answer, but this is not a better representation of a logarithmic expression. So we want to move it a bit further. But this is technically correct, but not a better representation. Why? We can actually apply logarithm, we can actually apply change of base to this logarithm because they are technically in the base of 10, base of 10. So if we apply change of base to this logarithm, it becomes x equal to log 2 to the base of 2 over 3. According to the change of base law, when we have logarithm to a given base divided by logarithm to the same base, you can take the logarithm of the numerator to the base of the denominator. So that's why we have log 2 base 2 over 3. So this is a better representation, and this is the answer, the second answer to the question. If you like, you can write it in the form of ln. This is equivalent to ln 2 divided by ln 2 over 3. So either this or this are better representation of this expression of this equation. So the value of x is equal to 0 or x equals 2 ln 2 divided by ln 2 over 3. So any of these satisfies this equation, and this is the complete solution to this problem. So you can see that the video is interesting. I believe you enjoyed it, and I believe this was clear enough. If you enjoyed it, please like this video, comment on it, and share it to your learning colleagues and your friends. And that way you keep supporting Knowledge Base. If you've not followed our page, please do follow our page. If you are watching our video for the first time on YouTube, endeavor to subscribe to our YouTube channel. That way you keep encouraging us. Thank you for watching this video and hope to see you in our next video.